Hello, this is Mrs. Leonard, and this is the video for the graphing output page for Earth Science class that we did on Friday, September 15th. The materials that you are going to need, you're going to need your notes that we took on September 14th and 15th on graphing. So if you haven't watched that video, or if you missed that in class on Thursday or Friday, you're going to want to watch that first. And then you are also going to need tape, a calculator, pencil, and the worksheet that looks like this. This is your output page for graphing that you should have gotten from Mrs. Leonard. Okay, so we're going to go ahead and get started. If you haven't already cut your paper in half and taped it into your notebook, you can see I taped in question number 2 first so that it's on the bottom. I just used one little piece of tape right here, and then I'm going to lay question number 1 over top and tape that in. And this is going on my output page. My output page is opposite of my input page. So your input page should be on page 3, and your output page for the graphing is on page 2. The reason we do this is so that way you can use your notes to answer questions over here. Okay, so we're going to go ahead and do number 1 here together. We did this in class together for most classes, and the most important thing for these questions is that you want to show all of your work. Okay, and the way we always do these practice problems, or anytime we do an output page, you're always going to refer back to your notes. So you want to have that handy. The first question says, if you want to read it along with me, the table below lists the average temperature, surface temperature in kelvins, and the average orbital velocity in kilometers per second of each planet in our solar system. So they have the data set here. And below, it says on the grid below, construct a bar graph. Aha! Very important. They've told me what kind of graph to create to represent the average surface temperature for each planet. Now I've underlined this and I put a box around this. These are important things, and so I know when I look at average surface temperature that I'm only going to be graphing this data, and I can see it here on my y-axis as well. So that means I'm ignoring this data. Sometimes they'll do that. This is actually an old Regents question from the Regents exam that you guys will be taking in June. They'll give you extra information sometimes just to try to trip you up, to make sure you're paying attention. Okay, so I always cross things out if I know I don't need them, okay, for a question. So for this, I can see it's going to be a bar graph. I've got the words down here, and now I don't have any numbers here. I'm going to have to create a scale. I need to create the numbers that go here. So if you remember, back over here, we have notes on creating a scale. And my first step is to count the number of lines on the axis. So when I come over here, I see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 lines. So I'm going to write that here so that I am showing all of my work, 16 lines. Okay. So what's our next step? Look at your notes. And I see that I have to subtract my highest value minus my lowest value. So I'm going to find my highest value on here. Did you think it was 440? If you thought it was 440, you're wrong. It's 737. So you have to be careful. Sometimes the highest number isn't always the one at the top, or it isn't always the one at the bottom. So just be careful and make sure you're looking at the whole entire data set before you decide. My lowest number is 73 as I look through my whole list. So I'm going to subtract 737 minus 73, and when I do that, I get 664. So what's my next step? Go back to your notes and look. I subtracted, and so now I need to divide by the number of axis lines and round up to find the scale to use. Divide by the number of axis lines means I'm going to divide by 16. So if I divide by 16, I'm going to use my calculator. Now I have a scientific engineering calculator, which you might not be familiar with. You can use your own calculator for this. Engineering calculators, you enter things a little differently. I actually have to add or put my number in and hit enter, and then oddly enough I put the number and then I say divide. You probably go the opposite way. You probably say divide and then hit the number in for your calculator. You should end up with 41.5. And then if I want to round up, I could round up to 42. But remember, this number is telling me how much am I going to go up by each time, right? So does it make sense to go up by 42 each time? Probably not. I've never seen a graph where it goes up by 42. It will go up probably by a nice even number. So you could go up by 45, but again, not often I see graphs go up by 45. Chances are it'll probably go up by 50, okay? Go up to a nice round even number, okay? And so if I go up by 50s, I have to start at least at 73. Now, if I'm going up by 50, I could indeed start down here at 70, right? A little bit lower than the 73. Perfectly fine. And if you did that, awesome. That means your next number is going to be 120. You're adding 50 each time. And then your next number will be 170. And then it'll be 220. And so on, all the way up, okay? But to be perfectly honest with you, it might be easier if you start off down here with 50 and then go up by 50s. It's easier to count it, right? So if this is 50, the next one should be 100, and then 150, 200, 250. And you want to look and think, how high up do I have to go? I have to go up to 737, which means I need to at least get up to 750. So I might pause here just to make sure I can make it all the way to the top. This would be 300, 350, 400, 450. Keep going and see. Am I going to make it up to 750? You can go ahead and pause the video and do this yourself and see if it works out. And if you're coming back, you're going to see whether or not this actually fits all the way up to 750. And it should, because I've done this before. And so once you have created your scale, I should be able to get all the way up to 800. Okay? And now once you've created your scale, now you are going to create your bar graph. So I'd like for you to pause. You can pause this and go ahead and create your bar graph. And then when you come back, you can see if you did it correctly. All right, so now you can see if you did this correctly. Mercury should be 440, which should be just a little bit underneath the 450 mark, right? Venus, the very next one, is the highest surface temperature, which is 737. So that one should be just in between 750 and 700. And that should be by far the highest bar that you have on this graph. Venus is the hottest planet in our solar system. It's like greenhouse gases and climate change and global warming gone crazy. Earth is 288, which should be right there, right? Because 300 is that top line, and then 250 is down below. Mars is very close in temperature to Earth. We actually sometimes call Mars our sister planet because Mars is very close in temperature, and it has an awful lot of other characteristics too. We have the same amount of daylight on our planet that Mars has. Jupiter is 163, which always surprised me about Jupiter being so cold, because Jupiter is a gas planet. It's made entirely up of just gases, not a solid surface at all. Same thing with Saturn. Saturn is also really cold, 133, about right here. And Saturn is also, actually all of these outer planets, Jupiter, Saturn, Uranus, and Neptune, they're all gas. They're all made up of gases. So it always really surprised me that these were all such cold surfaces on the surface of these planets. Because I always thought, wait a minute, if you're a gas, don't you have to be really hot? But these might not be gases that are familiar to us. These might be gases that tend to be a gas at a much, much colder temperature. So this is what your bar graph should look like when you are all finished with it. I'm going to set up a second video here so that way you can see how to do the second graph in case you're struggling with this, to at least kind of help you out with the scale, and you can watch that second graph separately if you need to. Okay, thanks.